Good evening, everyone. This is Tony Miracker, and welcome to our section meeting for May. We have a great evening planned for everybody tonight. So let's get started. Just a quick reminder before I hand it over to Lee. Tonight, the Toronto TTC is sponsoring this event, so take it away, Lee.
Thank you, Tony. So as the past chair of the Toronto section, I get the honor to be the chair of the Toronto Technical Conference, or TTC. So it's, I think as we previously announced, it's June 15th through 17th. I guess next slide. So just to give you a little bit about the format, so it's a 3-day event. Each day is sort of a very similar format. And what we've done is we've broken the day into, the day will start off with a sort of morning roundtable social coffee event. So it's kind of a networking opportunity to catch up with colleagues that you haven't seen in a while, try to simulate that real world or in-person experience. We then have a keynote for each day, talking about some interesting topics. Then we have a block of 3 presentations. So there'll be presentations on various sort of related topics. We then have a roundtable, which is sort of new to our conference this year. So the roundtables are basically different meeting rooms that you can go in and join discussions. So we'll have roundtables, which are Q&A sessions for the presentations and the keynote speaker, as well as the various roundtables on different topics. So there'll be someone there, and if you want to sort of join a topic on security or HDR or whatever, or battery technology and stuff. So there'll be various roundtables that you can go join the discussions, ask questions, participate in that. Then we have sort of presentations from our gold level sponsors, and then we sort of repeat that 6 times throughout the event. And at the end of each day, we also have a social event. So again, a networking opportunity to sort of catch up with your colleagues and have a bit of a sort of fun time here. Next section, or next slide. We do have our call for roundtable. So if you're interested in submitting a topic that you'd like to sort of lead a roundtable, we're still accepting new topics there. So encourage anyone, if you have a topic that you wish to sort of share and have some discussions, it might be something you want to present a bit of information on, it might be something you want to gather information, talk to people on a common theme of interest to you. We're having that. And we do have sponsorship opportunities. Our gold level sponsor sold out. We have 1 silver level sponsor still available, and then we have several bronze. So if you're interested in your company sponsoring the event, we do have some opportunities still open there. Next slide. And these sponsors are sort of help give us sort of various prizes and stuff. Our main launch will be next week. So early next week, you'll see an email blast from us. However, we are doing sort of a soft launch now. So the registration is open. So if you are sort of keen, you've been to the TTC before and you want to sort of sign up, the registration is there. The pricing information is available. There is a fee to attend, although the fee is quite modest and does have a lot of good value. To encourage you to sort of sign up soon, if you register before May 31st, you'll also be entered in a contest for various prizes. So we've got $100, $200, $300, $400, and $500 gift cards from they'll be available. They'll be drawn sort of randomly for people who have registered. So encourage you to register by the end of the month. We will be posting the program from May 17th. So if you go to the website now, there's not a lot of information. There's the information on the schedule and some general stuff, but by May 17th, next Monday, we will have a complete schedule of all the different presentations that will be available. And we are sort of having a variety of topics covered. So there'll be we're having 18 different papers through the 3 days covering the topics in the corner there. So for a variety of topics we'll be covering. So that's it sort of on the TTC. So do check your email next week for an email from us with more details. And I say if you're keen to sign up earlier, you can go ahead and check out the website there. Next slide. And I will now pass it over to our Canadian Governor, Paul, to give us an update on what's going on at SMPTE.
So hello, everyone. Welcome, and thanks for joining the meeting tonight. I'm Paul Briscoe. I past chair, past manager for a bunch of years. I had the good fun chance of organizing the last conference last time around, and now I know what Lee's living through. And so I'd like to give you a little update on what's going on at SMPTE and at the board. It's been an interesting year. First off though, hello students, welcome students. I hope we have lots of students on the call. I have this slide, I think this is NAB 2018 or maybe 2019. I do see a one Ryerson shirt in the back there. So it could have been 18 or 19, I can't recall which. But students are important to us. For SMPTE and so many organizations today, students are actually the answer to everything. Because, you know, as us old white guys get old and move out of the industry, you're it. So SMPTE's focus on students continues, and this has been very, very difficult through COVID, but we're still continuing to focus on that. And that's with things like career support and dues relief, as I'm sure you're well aware of, engagement opportunities and section involvement. I'll talk more about that later, but we really, I don't see enough students in front of the section here giving presentations and talking about things to shake us up. And that's really what we, I think, need. Anyway, in the past 8 years, SMPTE notes they've served 2,454 student members, and that's a good thing. In my first years at SMPTE, student members weren't even really counted particularly. So this is great progress for us. So students, please stand up, get engaged. We're friendly, we need you, we want you. You are the future of this organization we've all worked so hard to build. Who are the board? Well, here's some photos. You'll spot a few faces in there. This year's finance VP, of course, is our very own Paul Steckley from the Toronto Section. You see me in the bottom row there near the left, immediately to the right of Sylvain Muscat, my colleague, other Canadian region governor in Quebec. And in the center row, in the top row, just to the right of center with the blue background is Hans Hoffman. He's our new president. Hans from the EBU has been involved with SMPTE for a very long time. So present company perhaps accepted, we do have some very, very good people involved in governance in the organization. What do? Well, we try to run the society and governance operation. It's a confidential activity, although we publish summary results of our meetings and activities and so on. We haven't been meeting like we used to. There used to be quarterly face-to-face meetings, or at least once a year, and we haven't obviously had that in some time. So we've moved to completely online presence, which has been very, very good because it's enabled more participation, it's streamlined participation, it's forced us to streamline our document planning and our document management, and that's worked out really well. What the board does is everything from long-range planning through the annual technical conference strategy planning and enabling that. We manage finances, we manage the education portfolio, sections and membership, of course the standards activity, which is a huge, huge part of what SMPTE does. And of course we have an executive director, and that's Barbara. And of course we govern the elections as well. And of course we just had some elections, and I hope everybody voted. So what do we do this year? This year has been just the most interesting year, and I guess it's almost a year and a half now, isn't it? We've been coping with COVID, and that started out as tactical, and it's moved into strategic, because after a year, it isn't tactical anymore. At first, it seemed as though there might be something, you know, before not too very long that would relieve it, and it became clear that wasn't going to be the case. And it's been tough for SMPTE. We've lost a lot of revenue due to COVID. The NAB show this year, IBC last year, it looks like IBC this year. And the ATC, of course, is impacted as well by this. We had to take the ATC, the technical conference, online, and that changed a bunch of things, and we did okay. And it gives us insight into what we can do in the future. In fact, it opened our minds forcibly into looking at doing things differently. In addition, we have reduced staff salaries on a temporary basis at headquarters, reduced overhead. There have been travel reductions because, of course, nobody travels anymore, so that's kind of an organic benefit. There has been a little staff adjustment, some permanent staff reductions to restructure operations a little bit, and SMPTE did receive a forgivable payroll loan from the U.S. government, as many organizations did. So that's all good. Other bad thing, though, we've lost some membership. This is due to employment, due to COVID, and company sponsorships. Company sponsorships are down, and a big reason for that is actually acquisitions. When company X buys company Y, company X remains a sponsor and company Y no longer exists, and that sponsorship goes away. So we're looking at the sponsorship model, possibly improving that to make it more attractive, and we're also trying to engage other people from the new industries peripheral to us, which are merging, into our space. And we've done some operational changes to try and make things run more effectively. We've been very, very conservative in the solution space we're using. SMPTE is a very conservative organization. We have a very strong reserve fund we've built up over decades, and that is helping us out here. So at the moment, while we are at some level of risk, I would call that risk low. And the risk is the same risk the rest of the world faces, and compared to many organizations, we're in okay shape. Now, amidst all this, we were trying to reimagine SMPTE. We've had an activity for a while now to try and reinvent and modernize and re-energize SMPTE. And this is through things like cost management, new initiatives. And that's hard to do in the midst of the COVID thing, especially the initiatives, but we have still been pushing forward with those. And our interest, of course, in reinventing SMPTE remains very strong. There are a couple of good opportunities. One is new entrants to the market. Over-the-top television has never been a thing that's really existed within SMPTE, yet these people who do this stuff are out there and they do what we do. So getting these people engaged to SMPTE is a very positive thing we're working on, and this brings, of course, new members as well. We also have a newly revamped website. One thing about being stuck at home is you can work on your website. And we also have hired a new marketing director, Frank Kunkel, and he's doing a great job working with the website and all of SMPTE's marketing activities. So we have a lot of positive stuff that's happened this year, despite the fact that we've spent most of our time heads down trying to figure out what the heck to do. In our standards work, that continues. We also don't hold quarterly standards meetings anymore. That just isn't a thing, obviously, with no travel due to COVID. Nevertheless, we've been doing our standards work. We've moved away from our old platform, which was a kind of a bespoke platform built for SMPTE a number of years ago. SMPTE was the model for these people building their tool. And it got sold to another company and kind of got orphaned a bit. And so we're now on Microsoft Teams. And we're doing everything now on Teams, and that's working very smoothly. We moved to our virtual meetings. This is working very, very well. And it's cost positive both for SMPTE, for whom travel was a bunch of people and a whole bunch of kit going somewhere for a set of meetings, as well as participants. Now participants don't have to go to the boss and say, yeah, it's SMPTE meetings time again. Can I go? Can I go for 3 days? You know, the old fight for travel. So it's really actually helped the standards meetings. And most importantly, I think we've introduced something new. We've always written ISO standards. These are normative, rigid standards like nuts and bolts. And they don't fit the modern world where people write code and the code evolves and, you know, things just keep going. So we've come up with something called a public committee draft. And it's a way to publish things using GitHub or some other method, and we've chosen GitHub, to publish things which are early drafts. We also have something in line with this called a specification, which is different from a standard. It's the ability to write something that's less rigid than a standard, but it's ideal for software where things can evolve and where things perhaps are lightly specified as compared to what SMPTE's done in the past. So we're adding new pieces to our process to allow us to work in the new world, because let's face it, there are no rigid standards for many things in technology today, so much as there's recommendations and interfaces and APIs that define these things. So we are modernizing how we think about getting more stuff done. In the meantime, we did publish 7 standards in Q4 2020, so standards work does continue at pace. There's our little model. The one thing missing from here, if you look at GitHub, we use it for issue tracking, we use it for comment resolution. The one thing you don't see on here is software. GitHub, of course, is a software repository for people developing software, and that's probably our next step, is to move into an actual world where people are developing software as part of the standardization and specification process. SMPTE Education is doing quite well. Because of everybody being at home, it's a great opportunity for SMPTE to push the education, and a lot of people have taken us up on this offer. And so this has turned out to be a good year. We've discounted the courses, which has helped a lot in terms of people's ability to access them and you know, make it easy for them. And so far, the 2020 count total, I think, was a little over 500. We don't have a final count yet. And even though it was revenue neutral in the overall scheme of the society, it was a great source of revenue, but moreover, it creates mind share. If SMPTE's delivering education, people are going, okay, SMPTE gave me education, and that association in their mind brings value to SMPTE. So this has been very successful for us, and more courses are coming. This is just a list of the webcasts that have been done in the past year. This was 2020. So quite a large amount of online presence, and keep an eye on the SMPTE emails and the SMPTE website because this stuff is coming out on a continuous basis. Something new for SMPTE is SMPTE clubs. This is kind of an interesting idea. SMPTE, of course, has formal organizations, we have sections, we have standards committees, and so on. And what we don't really have are informal groups. And so we've invented a concept called SMPTE clubs. And I personally, I'm not a fan of the name, but it was a German who suggested the name, and I suspect club doesn't translate quite the same. To me, a club is a very, very informal thing. I'm not sure club is the right word, but actually maybe not so bad, because these are meant to be very informal, but they're topically oriented. So we could have a SMPTE club on neckties. Okay, that's silly, but it's a place where people with interest in neckties can gather and do things with neckties. Now, necktie is a stupid example. So if we slide on down here, you'll see the first one we kicked off. Peter Wharton, longtime SMPTE member and a friend, we got together with some other people and kicked off the SMPTE Cloud Club. Why the Cloud Club? Well, the cloud is a big thing. It's a huge thing. It's all over everywhere in our industry, and we don't have a play there yet. So this is one way we can get engagement with SMPTE and people who are in the cloud business. And the Cloud Club is going great guns. There will be more to follow. And if you have an interest and you think people would be interested in that interest, you can start a club. And I'm speaking to you, any member sitting at home listening to this, being a member. It isn't for the board, it isn't for your section board. Anybody can start a club. So if you have a topical interest, start a club, see who's interested. Next thing you know, you'll have a group of people like-minded with you, and that can then turn into a social thing. It can actually turn into something that turns into technology, which turns into standards work. Great opportunities. Another example of this is a recent club which just kicked off, the SMPTE She/Her Club. And I'll cantilever off this in a second when I get to the next slide. But as an old white man, and as there are so many of us old white men in the industry, we're finally realizing that it isn't about us anymore. And so we're addressing something a little different in SMPTE on the social side. But the She/Her Club is an indication of interest in people getting together, in this case, women getting together and figuring out their place in the industry, their place in technology, and hopefully figuring out what they need to tell SMPTE so we can do things better. And here's my old white guy slide. This is SMPTE. Historically, as long as I've been involved in SMPTE, it's been a bunch of old white guys. When I was a young white guy, it was old white guys, and now that I'm an old white guy, still a lot of old white guys. But here's our industry. And there's the old white guys in the middle, but women, men, different sexual orientations, different backgrounds, ethnically. It doesn't matter, we're all human beings, but somehow certain organizations have found themselves to be composed of just one thing. Thus, SMPTE has undertaken an activity that's now about a year old called the Diversity, Equity, and Inclusion activity. And the whole idea is that we address inequity. We address the fact that it shouldn't be about old white guys like me, it should be about everybody who's in the industry. It should be able to not only embrace people who are in the industry, it should open doors in the industry so there are no barriers to entry. This is really important. It's everywhere in the world today. It's part of normal life, and SMPTE, we got to be there too. So we do have this initiative. It's being led by Renard Jenkins. Renard spoke a couple of meetings ago at the Toronto section here. And the whole idea is we increase the awareness of diversity, equity, and inclusion at SMPTE through every means possible. And one of the things we're doing, and just you can find out more about the activity online, of course, but one of the things we're doing on the formal standards front is we're actually doing, as other organizations are doing, and going through standards to remove some of the today offensive, once upon a time less so offensive language. One example that gives Lee and I cramps is the language around master and slave in the PTP standards. So that's being worked on. The other one is whitelist, blacklist. Yeah, it's actually, when you stop and think about it, that's kind of a bad thing to say. If you're a white guy, yeah, it's a good list. If you're a black guy, it's a bad list. You know, it's good that we reevaluate our language, and it's good that SMPTE is paying attention to this. So in terms of gender, in terms of race, in terms of anything, we're trying to figure out how to make SMPTE as open and flat an organization for all human beings as we can. So this is a very important activity, very different from what SMPTE normally does, and I wanted you to be aware of it. By the way, picking the name was kind of hard. These three letters are mostly taken up: IDE, IED. EDI not so bad. IDE is, of course, a holiday. DI is probably not good, so hence it's called the DEI activity. Going forward then, we're in okay shape. We have challenges, but we're very conservative and we're very careful about how we spend the money. And so far, SMPTE has been able to continue doing what SMPTE does and undertake some new initiatives. So we're feeling okay for the moment. And the forecast right now looks okay. If COVID continues to decelerate as it appears to be by the end of this year, perhaps, then we come out of this in pretty good shape. We have a new streamlined standards platform, which will enable us to do standards more quickly, with more engagement and less time just juggling the paperwork and the logistics. We have a brand new marketing focus in SMPTE and a brand new website to reflect that. And this has led to social media and increased engagement because we have a marketing group now paying attention to our social media presence. We've expanded the education portfolio that continues to do so, continues to occur, and there will be new courses added again this year. And we're finding new ways to do what we do, partially forced by COVID, partially forced by our awareness as a result of COVID, and partly this sort of waking up to the modern world, looking at ourselves and trying to figure out how we can rejig ourselves to really fit and deliver the same value we've always delivered. And that's the whole idea of the DEI program. And the elections, we had the elections. The results should be coming, I think, the end of this week. So candidates, good luck. But to everybody who didn't run in the election, do you want to help? Maybe you don't want to be a manager on the board, but you want to help out. You're not sure, maybe the time commitments are a problem. Speak to a board member, call one of us up, call me or call anybody on the board and just say, hey, you know, I'd like to help out in some way, but I don't have much time, or I don't know very much, or I only know about audio sweetening, whatever it might be. Talk to us. I'd love to see more strangers giving presentations and more people we've never heard from before stand up and talk about something and get us interested in something we don't know about. So don't for a second think you're in front of a room full of experts and you don't know anything. We don't know what you know. So come to us, tell us if you want to help out. We'd love to have you help. You don't need to be an elected manager, but hey, it may lead to that. You start with the light stuff and the next thing you know, you're hooked on the heavy stuff, says the next manager, ex-chair. And we're always available. Your board, we have emails and phone numbers for us. You can get hold of us anytime. And that includes me. Please ping me if you have any question or comment or anything you'd like to talk to SMPTE or the board, either the section board or the main board about. Ideas for the section, SMPTE Society overall. And all you got to do is contact us, open the door, and we're happy to talk with you. And with that, I would like to throw it back to whoever picks it up from here, and I think it's Mansour.
Yeah, let me just do a couple of slides here, Mansour, and then I'll hand it off to you. So tonight's meeting, Display Technologies and Digital Signage, is actually, it's been arranged by Mansour Madafi and Andrew Thomas and Kevin Leiber. They put a lot of work into the presentation this evening. Our evening protocol tonight is Mansour is going to introduce and read the bios for everybody. Andrew will be managing the question and chat board. We are going to ask you to hold off on your questions to the end of all the presentations, but you can upload them at any time and Andrew will pick them up. Yeah, I'm going to hand it over to Mansour and he'll take it from here.
Thank you very much, Tony. Good evening, everyone. Tonight we will have very exciting presentations. In fact, we have 4 presentations and 6 speakers because one of the presentations will be done by 2 persons, 2 speakers. The first speakers for this evening is Jim Vair, President of Chapter Networks Limited. Jim will speak the evolution of the digital signage. Jim joined Chapter Networks in 1997 and has been involved in the execution of all major projects undertaken by Chapter Networks during that time. Jim has been instrumental in transitioning the company focus from its roots in broadcast and cable television to include digital signage and out-of-home media. During Jim's tenure, Chapter Networks has expanded the client base and sold products and services into more than 40 countries worldwide. Prior to Chapter Networks, Jim worked as a professional engineer with an engineering consulting company after graduating with honor from a Bachelor of Science engineering program. Thank you for joining us, Jim, and welcome. Virtual floor is yours.
Well, thank you very much for introducing me, Mansour, and thank you very much for allowing me to present tonight. This is a presentation. I was asked to kind of go over the evolution of digital signage and lead that into what the current trends are for this communications tool or communications medium. As I was introduced, Capital Networks was a company. We just celebrated our 30th birthday. We're located up here in Markham, Ontario. And our software platform is referred to as Audience. That's what we market under. So if I say the word audience a lot, I may be talking about that. But in 1991 is when this organization started, and we started definitely in the cable and broadcast world. But you'll see through the evolution of the products that I talked to you about, how it's been a natural migration or evolution for us to get into the digital signage world and out-of-home media, and some of the projects that have led us there. So just to back up, the role of visual communications in today's environment is kind of a theme. And what is digital signage? The definition commonly used is it's a centrally controlled content distribution platform, which people can, from one central location, control and schedule, forward and store, or otherwise stream content to a wide connection of different endpoints and used for many different kinds of purposes. My company is a digital signage content management system organization. We're a software company. We've developed a platform called Audience, and that's the platform that we use to help all of our clients with their channels or with their presentations. And how did digital signage come about? We've been asked this a number of times, and we've spent some time thinking about it. The founder of Capital Networks was a man named Bill Trainer. He successfully retired last year. But Canada has a large number of companies, software companies in particular, involved in the digital signage industry. And I was always wondering why it was that such a concentration of software companies got into the digital signage business. And back in the old days, there was government support and interest in different technologies, including going back in the 70s to NAPLIPs. But then, government regulation also in the mid 70s, the cable companies wanted to get into the advertising business. And at the time, they were lobbied and said that might not work out well. So the cable companies got into alphanumeric, kind of an exception to the rules. And so what they started to do, given our geography in Canada, where they would have headquarters in some cities and lots of different locations where cable systems would be, they wanted to manage and control everything centrally, and then forward and store content out to their head ends and have those head ends produce signals. And so that's really how we got started. And we started in the business. Our first product was with Rogers Cable for TV listings channels, and those continue to be on the air today, believe it or not, and in different shapes and formats and sizes. And we still do it with a number of different companies as well. Local news and advertising kind of channels, who again followed that same migration. Real estate channels were popular for a while. And so digital signage isn't really a new technology. It's been around for a while. It's even had its out-of-home origins. This is a project back in 1986 at the Copa Club in Toronto. And there are old TVs that were hung on the walls with different kinds of schedules over the coat checks and places where people would gather, showing menus and things like that. It's just migrated and evolved and grown and started to use different kinds of technologies and ways of accomplishing the same thing. In 1998 to 99 is when we got involved with CP24 in the Toronto area. You may be familiar with it. This is how it originally looked back then, with the SD presentation. And this was a multi-zone presentation where the whole bunch of, this was new at the time, where a whole bunch of different content areas on the screen did news, weather, sports, financial, lottery, all those kinds of information. And very shortly after that, we started, since we were involved with the platform that got this going, we started getting asked for, people wanted their own CP24 channel. That's how they would start the conversation with us. And since they all didn't have licenses to broadcast, this is how we got into different private networks and ways of using our software to help people with their communication needs. One of our earliest digital signage customers was a company called the Elevator News Network, and it was a Toronto organization. And by the time they got to us, they had a few buildings in place, and they just put laptops at the time in each elevator cab, and they were looking for a better solution. Back then, laptops were about $3,500 items. I guess they still are about that, but they couldn't play video back then. And they wanted a solution, and so we helped them with one. And at the time, we had to provide two different broadcast servers, one to play videos fed into the other one for the alphanumeric content, distributed over the traveler cable into the elevator cabs. And it was a very expensive solution, but they got up to 108 buildings before they were purchased by another company to continue on. And that company continues to this day doing in-elevator advertising and messaging. Things progressed and things evolved, and this was another example of a out-of-home or place-based or digital signage customer. This was a collaboration between the CBC and some other folks in airports across the country. And again, central to the theme was they had they had their central operation facilities, and they could forward and store content to the different airports, and in waiting rooms or lounges or baggage claims area, they had screens in there, and the content was distributed over SDI to all the monitors, and they were able to do some advertising and some messaging. And this brought us to, and I hope this video plays okay with the connections for everybody. This is how it has evolved to, just go back there. There we go. To what some of the digital signage is today. This is a screen in South Korea. It's a rather large outdoor LED presentation, but the resolution and the graphics that they're able to do, you see some small ones at the top, but it's the large screen I'm talking about here. And it's digital signage is creating attraction and engagement and augmenting people's environments. And this presentation with its aquarium and the wave is something that's got a lot of attention these days. Is kind of the future and the way that digital signage is going to continue to evolve and shape our environments all over the place. Okay, let's just go on. So instead of digital signage, you know, I've never really been all that comfortable with the expression digital signage. It's not a great term. Really, we're helping a lot of our customers and organizations that we work with communications. It's just we're using a visual communications tool to help them do that. And the visual communications in our lives is very important, and all communications is. And using the videos and the images and the text that we're able to do, we're helping people deliver more information more directly. It's much more flexible than verbal communications. It helps people retain the information that they see better and helps convey ideas clearly and effectively. So you can imagine a lot of different environments where using and or interfacing with other systems or solutions that they have to share in real time some of the content or information can be very effective and keep people aligned and help achieve the goals that they're looking for. This applies to a lot of different environments. We have worked with a wide range of people across all of these different industry segments, corporate education, a lot of work these days with municipal and government, healthcare, hospitals, and retail, very successfully. It is quickly becoming a very important role for all of these people as part of their communication strategy. These days, of course, it's, as we learned in the introductions, it's all about health and safety, no matter where you go, and having screens that are able to clearly and accurately provide guidance or information, let people know how they're supposed to behave today in this environment that they walk into, even though it's the same building maybe they walked into every day for 20 years. Today they might have to act differently than they used to do. And having a screen there to reinforce policies or demonstrate things can be very useful and effective for these people. Wrong way. As well, in all the places we go, be them community centers, hospitals, our work environments, restaurants even, all the systems that those organizations are using are getting a lot smarter. There's a lot more data, there's a lot more measurement. And so having a solution like digital signage to be able to reflect in real time some of the things that these systems are able to measure can increase the adoption, participation in those systems, help share the knowledge, and maybe get people to have a better experience. So in MDUs or apartments or condos, we're working with energy saving systems to kind of gamify the energy savings goals that they're trying to achieve. So they're able to show on screens what the energy utilization, for example, was in a building last year or this month, and how the building is tracking this year. And maybe by showing that on the screen and having a few suggestions alongside of that data, they're able to compel people to help with energy savings. In hospitals, there's real-time locating and tracking so that the nurses and the porters and the doctors can be efficiently managed and directed where to go. Lots of presence detections, even we can show a few examples. I think I have in upcoming slides where even putting sensors in rooms to let people know how many people are in a room before they open the door to go in that room. You can imagine these days in hospitals and laboratories, even public bathrooms in malls. That might be areas where people want to know how many people are behind that door before they open it to go into that. All kinds of other KPIs, social media, live events, things that people are using for digital signage for. So these days, it's all about creating an ecosystem or an integrated environment that digital signage can complement. There's an installation in the Humber River Hospital in the Toronto market where we have deployed 1,000 uniquely addressable digital signage screens in that one building. The majority of those screens are what they refer to as patient room status monitors. These are screens outside of every patient room, but they're integrated with the electronic medical records system of the hospital so that we're able to share in real time any precautions or alerts or risks that doctors, nurses, or staff need to know, or visitors, before they walk into a patient room. This could be what kind of personal protective gear they should wear before they walk in, or if there's any allergy risks or things like that for those patients. It was a challenge for them before. This is replacing solutions that included such elegant solutions as putting different colored sticky notes on the door frame. That would be the color codes the nurses used to use, but you can imagine sticky notes would fall off the door frame or not be updated at all. But now everyone is comfortable with the fact that the data is coming from the electronic medical record system. That's the single source of the truth for this data. It's always accurate, it's always update. We can reflect it in real time. It's proved to be very useful. The other channels in the hospital include screens in their waiting rooms. There's also meeting room schedules, hospitals, a place of work, wayfinding, of course. Lots of different ways that they can use emergency messaging, and they can press one button and all the screens in the hospital could start to broadcast their emergency messaging. And so having one platform or one system able to coordinate all of that for this organization is very helpful. Municipalities I mentioned in Canada, they're also organizations with lots of different communications challenges, the needs of a library versus an arena versus town hall versus their garages for their employees versus their water department, their fire department, their transit department. The HAL has to be supported by one IT group. They can't have everybody running off and running different systems to do different things. They have to have an integrated system, but still have a platform that's flexible enough to allow everybody to do their own messaging that they need. City of Hamilton is a growing customer of ours. In the first 2 years, they've deployed just about 70 addressable screens. They have plans for more. We also work with other municipalities in Ontario, including Markham and Newmarket, Waterloo, and lots of other ones that we could talk about. This integration of environments, we even simple ones like the Chelsea Hotel in Toronto. I mentioned this because this particular customer, their IT staff woke up one day and realized that they were supporting 4 different digital signage platforms in their place, and that was not something that they wanted to do going forward. So we helped them rationalize everything and get it on one platform. And very simple things like menu boards and event boards, welcoming guests in the rooms, welcoming guests in the hotel. It's just a style of communications people are used to getting information from these screens, and having an effective system is useful for them. But also, what some people consider non-traditional digital signage environments, manufacturing facilities or other blue-collar environments. There's lots of real-time health and safety information that is important to share. This customer, Toyota Motor Manufacturing, they have 3 facilities in Ontario. They have 220 displays. They do a lot of real-time town hall meetings, events, announcements. That's all streaming live video to these screens. They also use the same screens that they use for scheduled presentation of content for training tools. They can trigger and play safety videos on demand or other training tools on demand. And so it's just another resource and helps them quickly and efficiently with their communication needs. The hospitality section, hotels and restaurants and stadiums. This is a restaurant chain that people are familiar with in Canada. They have 4 different channels of digital signage available for their different franchisees, including very, very data-rich presentations with live sports information on them that is customized depending on where the restaurant is and what home team they may cheer for. In Canada, they have the home teams in basketball and baseball, just one team, but in hockey, you have lots of different options for what people may want to select. So the new trends and some of the new solutions that digital signage is being asked to do around COVID, just like was talked about earlier, we're able to focus on working on our platform and trying to meet the needs of people and with the challenges. Interactive kiosks have always been popular digital signage, but these days people are a lot more interested in contactless ways for interactivity. So some of the contactless ways that you can use interactive kiosks can include just using your voice, being able to talk to the screen and asking for directions to different areas, or using gestures. You can use your hands without touching things or your feet to press virtual buttons to be able to navigate through different menus to get to things, or providing the ability for people to use their own phone, either maybe tapping an NFC tag or a QR code to get the interactive experience on their own device, and either using their own device to control the screen that's in front of them or having the interactive experience transferred to the device that they're carrying with them. Digital access control has become much more important and interesting this year for people, taking advantage of cameras that are counting people in spaces and being able to put up on screens at the entrances or barriers to encourage people to wait until the certain number of people reduces and it's safe for them to enter. And so interfacing with these camera solutions and taking advantage of the real-time data that they are collecting and just reflecting that on screens. That's a good application of digital signage. Two-way digital greeters, being able to use digital signage as a tool to convey messages as people are walking or approaching in a place. When they get within a certain distance from the screen, have a presence detector be able to trigger or prompt a two-way video call between that kiosk and maybe a person at a reception desk, a central reception desk. That person at the reception desk will be able to toggle between and manage calls on numerous different kiosks, but be able to have a video conversation to ask the person questions, get them to complete a survey if they want, forward videos or graphics to that kiosk and show people what they need to see, or provide them a video to watch before they enter a space and then buzz them in. As well, as I said, interacting with phones is very popular in a couple different ways. These devices that we're all carrying around with us are quite powerful, and either having them being able to pull information from the digital signage screen that they're standing in front of, so they can take it with them if it's something that appeals to them, or being able to use their phone as a way to trigger content on the screen that they're standing in front of is another effective way to integrate and engage an audience and get them to respond to these screens that are popping up all over our environments. And so that is my introduction and brief history or the evolution of digital signage. So I will try and return my screen. Oh, you can take my screen away. Thank you very much for the opportunity to present.
Thank you, Jim. It was so interesting to see how this digital signage industry is big. It's a huge industry, actually. For the next speaker, the second presentation, actually tonight, we will have two speakers, Darcy Pickering and Danny Ljubisic. I hope I pronounced his last name correctly, from Bannister Lake. I'm going to introduce both of them here. A graduate of OCAD, Darcy has over 35 years of broadcast and production experience, covering broadcast and post-production graphics workflow for broadcasters and broadcast manufacturers. Prior to Bannister Lake, Darcy was the cinema product manager for Christie Digital's first DCP Series 2K DLP cinema projector, working directly with cinemas and post-production pioneers like eFilm, ILM, Laser Pacific, Pixar, and Technicolor in the early days of DI, means digital intermediate production. As a member of the Cisco Systems Pixstream's product marketing organization, Darcy was responsible for Cisco video networking products and played a key role in defining new products and marketing strategy for early broadband video over IP, and ad insertion application, working with clients such as SBC and Bell Canada, while serving as a product manager for Inscriber Technologies, a line of broadcast television product. Darcy developed in broadcast graphics production workflow with customers like CNN, ABC, NBC, and Bloomberg Television for their on-air graphics presentation. He also managed and marketed Inscriber's innovative high-definition character generator for post-production and broadcast television. He's an active member of SMPTE Toronto Chapter. And now let me introduce Danny Ljubisic. Danny is the Director of Business Development at Bannister Lake, focusing on driving a new business through production, improvement, and innovation. He has over 20 years in the broadcast software industry with experiences ranging from quality assurance, support, development, sales engineer, and product manager. Danny bridges the gaps in communication between these groups by translating jargons and simplifying complicated concepts, capturing customers' desires and turning them into software requirements for technical features into easy to understand sales and marketing points. Danny has focused on improving the user workflow experience is what provide his daily motivation. I'm very happy we have Darcy and Danny among us tonight. Please take away, Darcy and Danny.
Thanks for the introduction, Monsieur, and thank you, SMPTE, for the opportunity to speak with you guys tonight. I'm sharing my screen. I believe you guys should be able to see. So what we're going to be talking today about is automated graphic workflows. And what we're going to be focusing on, or my focus here today, is going to be the data side of it. Graphics and everything are quite pretty, and we're talking about digital signage, but at the end of the day, content is king, and this is what we're going to sort of be focusing on. Before I go too far into, of course, what graphics are, I think what we do is need to define a little bit of what we're talking about. Now, of course, graphics, and especially the SMPTE group, seems pretty easy to sort of understand. Graphics can be a photo, it can be an image, but when we're talking about graphics for tonight's discussion, this, for example, is a graphic. it's just a bar, we could use it as a lower third. Another type of graphic could be a logo. But this isn't really what we're going to be talking about today. I mean, a logo still represents something. It has data, it has representation such as branding. An icon, also graphic, yet it has meaning. It could actually potentially represent some data. In this case, I think we can all universally recognize this as a rain icon. It bridges the language or barrier as well. But for tonight, what we're going to really be talking about is this type of data visualization with graphics. And it's very similar to what I think what Jim was showing just a few minutes ago with some of the digital signage. But we've also seen this a lot in broadcast. And what we're doing is talking about these type of information screens. Now that's on the graphic side. How does data relate to that? Well, these days when we're talking about data, there's a lot of different ways we can look at it. Google, certainly Facebook, has really confused things. What's our personal data? What data are you collecting? Is it just, again, personal data, habitual data, and things like that? Is the data public or is it proprietary, for example? Do you have rights to use that data? Can you rebroadcast that data? Again, social media has blurred a lot of that. Although, you know, content is available online, it's not necessarily free just because you can view it there, and yet on some platforms it is. What we're going to be talking about tonight is really data sources, which were typical sort of like our news sources, weather, sports, financial data, possibly even alerts and things like that for school closings, even in the broadcast domain. Social media as well. These are the new types of things. What I might want to separate personal or public or proprietary data. The data that we're talking about here might be considered consumer level data. So again, news, sports scores, publicly available data. Okay, so where did we come from? I think it always helps to know sort of how things kind of got started. And I'm going to be talking a little bit sort of in the data world and sort of the merging of two markets. We're going to talk a little bit about broadcast as well as signage. So this is how we sort of overlap with our earlier presentation. Well, of course, where we started from, a very manual process in broadcast. Data would come in either to a TV station, whether it was phoned in by a reporter or even a telegraph to come in across distances. We would have to manually enter that data into some type of device and then display the graphic. Now, obviously, it was rudimentary graphics here, very simple CG teletype machine. On the signage side, again, where did we come from on that? Well, just short of a rock and chisel. I mean, signage, and we're not talking digital signage, but where did signage start? Posters, whether we were putting up posters, whether we were putting up billboards. These were our first forms of signage. They provided a message, often advertising, but they could also be informational, especially during elections and stuff. You would see a lot of campaign posters, so it's a little bit of both. But of course, another diagram here, this is one of the schools that we sort of participated with. Here's a form of their signage. We were moving them to digital, and this is where they started from, a whiteboard. Very often we see billboards. So this is really the start of us trying to present information, whether it was color-coded or sticky notes, I think was an example from before. Very manual process, very error-prone process, but this is how it all started. Then as we evolve from there, we start looking at what I refer to sort of as the single workstation stage or process. Here on the broadcast side, we would actually have a tool or an application. The tool would be locked to the particular facility. You wouldn't have access to it if you weren't inside the building. Very often the tool was a dedicated workstation tied to a single computer. So if you weren't at that desk or at that studio, you couldn't access the data. Data was locked to a file, if we did have files, if it wasn't still manually entered and just simply stored there. But it's a flat file system. Potentially if there was a network, for example, and they had multiple display systems, they would have their own files, in which case you can end up having multiple versions of a particular file, and therefore information becomes out of date and inconsistent. So there's obviously problems in that, but what they did is obviously evolve using files to store stuff, and then of course the computer to be able to manage things. On the signage side, of course, slightly different. The displays have evolved. Okay, so we're no longer putting up posters and gluing, pieces of paper around. The signs have evolved, so now we have television displays that we can actually display media, whether it was videos or moving pictures, or at least now the locations of these signs could be showing something more than just one poster at a time because it could cycle through the media. However, all of this is still quite manual as far as the process goes, as far as getting data and content to these displays. In the signage world, all of this media would have to get updated. You'd have to still travel out to the site wherever the displays are in order to be able to update that content. Evolving to the next stage, we have our networked environment. Now, in a networked environment on the broadcast side, it might not look that different, but there's some significant changes here. Here we're in a networked environment where we have multi-users. Once we have a multi-user, you see some significant differences where you have to have different user levels. So the data engine and the database needs to be able to support, for example, an administrator level versus an editor versus a producer in the case of broadcast, somebody controlling the rundown. Doesn't look that different, but the evolution here, at least in this particular diagram, is showing the data is now actually coming from real-time sources. It's not simply file-based or file-locked. The World Wide Web has evolved, so we were actually able to get real-time data from some of our traditional news sources, for example, AP News or something like that. We're reading the sources and bringing that all back in. But the key here is that we have editors now that can moderate the data. It's not just about displaying the data, it's about being able to control the data and then control what goes to different regions. So again, all very data focused on this. The signage side improved a lot as well in the networked environment where you can connect to multiple signs at a time. So now we actually have a lot more flexibility. And of course, in an environment like this, we can drive blocks of signage. So if it's in a venue, for example, you can have the upper concourse with premium seating, and they can have certain presentations and different levels of signage or advertisements on the premium. So for example, your Lexus commercials up on the upper concourse, while in the lower concourses you have Toyota commercials or something like that. So we can create the groups, and it became a lot more flexible. Still had to go on site, I think, for a lot of these because the networked environment still restrict you to that building, basically, to that physical area or resource that you're broadcasting to. But what you can see is that each of these so far have been growing in the same direction, both from the display point of view, they're becoming more sophisticated. The data is becoming a little bit more real time, and we're able to connect to more than one device at a time. And this brings us to our stage of today, where basically what I'm referring to is the cloud stage, where we've gone that step past networking itself, and in the cloud environment, we actually can merge basically signage, and broadcast, and even take it a little further to the web. To explain a little bit what we see here, it's still a multi-user environment, but here what I'm trying to represent is that the users don't have to be in the same location as they did before in the networked environment. They can be anywhere in the world because we're connecting to cloud services. Couple of things that, of course, as a data provider or as a data solution, you need to take into account is now that we're actually accessing our data from anywhere in the world, security. We had our user levels, content groups within the networked environment, but here in the World Wide Web, we have different ways of, for example, logging in. We can have our own password, username and password to log into a system. But today, of course, in a cloud environment, taking advantage of being able to use sort of Google security to log in, as well as still for some broadcasters, for example, Active Directories or LDAP and stuff like that. So we're any of the data management systems are able to leverage some of these other technologies to sort of bring that all together. Now, also what we're showing here is a variety of data sources. And very important in today's world is our audiences. They've come to expect data in real time, and they've come to expect it at their fingertips when they want. When it comes to social media, they like to see their posts, they like to see that interactivity like immediately, and they're used to that interactivity. So here, whether we're in the broadcast or the signage world, we're trying to bring some of that back. And we're able to now in the cloud environment or architecture where we can connect to these data sources and bring that real-time data back right away. So whether it's pulling information from social media, breaking news that might come in, it's all coming into a centralized platform so that now we can make it available to everywhere else. Now, of course, key once we come into the sort of cloud environment that we see here is your database or your data source to be able to support, for example, Unicode. We have to respect the fact that our data is now going to be going outside of our individual areas potentially. So to be able to have support for all languages. Also in the cloud architecture, we introduced sort of in the center here, try to represent web outputs. I mean, signage is video, and we can stream to that. Broadcast, we're familiar with. We, our solutions are doing that already with SDI or NDI output. But what we're seeing is also that content now, and what you're really looking for in your data solution is the ability to share that content. So the same way we can share that content to broadcast, we want to be able to share it to signage. We want to be able to share it to a website, whether it's a widget, or be able to provide the feed to mobile devices in a JSON format, so that data is shared. Now, why is it important to share that data? Well, because earlier on, we moderated it. So maybe in a particular region, we're not showing all the national stories, we're showing the top 5 because it's relative to a particular region. So of course, it's very important for us to be able to control and moderate the data that's going out to those individual signs and locations. In the cloud environment, I mean, whether we're hitting broadcast devices, so graphic engines from Expression to Chiron, VizRT, all the way to the signage side, whether it's BrightSign or Omnivex. What we're doing here, or what you're looking for in any of your data solutions, is that agnostic ability to be able to provide that content to any device today. It's expected today. We're not, we can't have it limited. Okay, so with that little discussion as to how we got here today, let's talk about some practical examples. And of course, we have a few customers that we've worked with. So I want to sort of highlight what they're doing and how that applies to what we just talked a little bit about. So here, of course, hopefully you recognize some of this, CTV News Channel. In this particular use case, and what's key is all of their data sources are coming in, again, to a centralized location. Key to any of this is populating the template that they have here in an automated format. There's actually no human intervention that runs this channel on a day-to-day basis. The headlines come in automatically. If there's a breaking story, the data actually triggers itself so that an additional crawl can appear up on air. Within the organization, they have different user groups. So there's an editorial group which can actually control different stories that will actually go out to air. Once they've set that playlist, they don't typically change it. And then they have an editorial group that can look at the content. They take a look at their RSS feeds to make sure that they're following latest headlines and content like that. Of course, the key here is all of the visualization that we talked about before. So whether it's the icons and visualizing that content, there's also the opportunity for sponsors and showing the sponsors and advertising logos that we have in the sample here. Now, in the broadcast world, we are talking about data, and so far we've been talking a lot about like these news channel data, again, that consumer data. But in the broadcast world, there is other types of data, and that goes as far as, for example, program scheduling. So the content that's there, and this isn't that different than in signage if we were looking at a particular schedule. In this case, we're looking at a very specific channel schedule that when we centralize that, and in the example with TSN, they have 5 different feeds, but what they're able to do is cross-promote across the different feeds. So if you're not interested in whatever sporting event that's about to come on our second feed, please take a look at one of our others, because of course what we're trying to do is encourage our viewership to stay within our network if they're not interested in that one particular channel. And this also allows cross-promotion from one event to another. Now, of course, the advantage to some of this is also, as I described, the data is agnostic to the output. So regardless of how they want to trigger some of the branding elements, the real-time data is always available. So in the case of breaking news, as I said, as soon as the data arrives in and is classified as breaking, it goes directly to air. What other types of triggering mechanisms, of course, are GPI, serial triggers, triggering over IP. From a data point of view, it doesn't matter. That centralized database must always be available, so high level of demand. Now, the broadcast, I think a lot of us might be somewhat familiar with being members of SMPTE. And of course, signage is a bit of a new market. And of course, I was comparing signage as the evolution of. And what I'm showing here is going to look at one use case, but there are, and as Jim said, you can see that there's just this huge variety of specific markets that signage applies to. A couple that I wanted to just sort of outline here, for example, train station. So here out in BC, we're global in Pattison, they're running an ongoing, basically it's got the schedule, it's got localized weather. So within the database and the centralized data, we have all this weather data, and what they're doing is actually issuing a query So key to, again, the data side of it, being able to manipulate the data so that way for each station they can query and deliver localized weather to each of the signs that are there. Same thing with the train schedule as well, providing the schedule. And of course, this is a source of ad revenue for them, because once they have eyeballs on the screen looking up at the content that's there, they're going to see their sponsorship. And of course, there's ads run logs as well to monetize or to be able to provide billing systems after the fact to reconcile how many times a logo has been on air. The other sample in another growing sort of market, and I don't know if it's sort of venue related, it's very broadcast, it's esports. Esports is this huge growing venue market. I believe just last year, I think it was Fortnite, they had an actual purse where the winner got $1 million. I think that was the first time an esporting event actually had $1 million purse at it. So it's actually growing. We may not know of it. It's not as well known as NFL football, but it is certainly growing and it has a huge fan base. And here, what we're looking for is data flexibility. Any data solution needs to be able to, for example, be flexible enough, and so using key value pairs with a relational database, so that way we can handle complex data sets that come from these gaming sites. There's a lot more data, there's a lot more participants that are participating in these kind of esporting events, so there's a lot more that our data system has to handle. Sure, we can visualize it afterwards, but the key is, of course, the data, centralizing it and making that all sort of available. So of those examples, the one that I want to dive into a little bit more is we did a little work on the US Open. And key, of course, here is multiple data sources, of course, thousands of XML files providing just real-time results from all the different matches that are happening at the same time. So what we're able to do here is and just a quick shot of like sort of what the screen might look like, is the ability to normalize all of this data from the different sources, whether it was the XML or different MST feeds, also, of course, the league itself. The normalization of this kind of data allows us to be able to share it among other devices and make it very easy to use and consistent through that. We're also incorporating some social media sources that we did for the event. But once we've normalized the data there, it's easier to write queries to be able to pull the results. So for example, rather than having to constantly create a leaderboard of the top 10 players, we can actually issue a query. The query will then actually go through that database and provide you the top 10 players. So you're not constantly having to shuffle that. It is automated in a sense. Using a RESTful API, being able to pull via URL for other devices, basically a query of any of the data types that we have here. Going past the data, and what I mentioned was, as far as the display devices in that diagram, what we want to be, as far as a data source and a centralized data source, is agnostic to the display device. So here what we're showing in the US Open, for example, is a couple of different displays, all being driven by the same centralized data source. So the ribbon board that you see here, again, different devices, odd resolutions. So of course, we're doing like a few thousand pixels by only a few high to generate these ribbon boards. But the key here is being able to deliver the data. This was an octagon, so there's actually 8 sides to this ribbon board. But basically running the odd resolutions and providing weather information, match and practice schedules, as well as final results that you can kind of see here. Same data, same centralized source. Up on the top right of this particular image, you can see a little bit more of an L bar. It's actually a reversed L bar with content across the top and the right, and then the match playing. But again, here's an example of this venue signage. But key to driving all of this is managing the data and the vast amounts of data that are coming in. What I don't have here is some of the Facebook posts and stuff that they would have on some of the screenshots. They incorporated those as well. Just one more shot from the US Open here. Again, what you can see from the main stage, just in front of the Arthur Ashe Stadium here, is on the left and the right, basically main boards, where they're both showing matches from different courts, as well as what can't see the graphics necessarily, but the L bar, the presentation where we're showing, again, practice times, final results, and the actual in-game match. So all of this real-time content. Now, one of the things that we're showing here is obviously some of these are LCD screens. Some of these screens are being driven through, SDI. Expression Tessera was driving a lot of the Arthur Ashe Stadium content, while they had other graphic devices running other screens, LED screens throughout the facility as well. Simply reading the data, and again, normalized data that we had inside the centralized database. Interesting that OTT was mentioned, and I thought to actually sort of introduce something that's a little bit, it was broadcast, but it's something that's new and that we're actually kind of seeing, and broadcasters are obviously moving toward it. One of the key advantages or assets that we see with our centralized content or centralized database is that in OTT, we're using the same data set. Basically, what we want to broadcast is the same content or the same type of information that we're seeing on our regular broadcast. But what we're doing here, and again, the key is to having that centralized data. What we're showing is an example here where a number of different feeds are available for the different regions. Having that centralized data set allows us to query, for example, the weather so that we can deliver the specific weather for each of the regions based on the feed. Now, what we're seeing with OTT, of course, is cost-effective hardware, the technology to do the rendering. We're using Chromium, for example, in a lot of cases, to be able to, again, visualize the graphics or the data that we see here, and then be able to provide that in a regionalized and cost-effective way. And we're seeing more and more of this growing. I mentioned the low cost for hardware. In this particular case, the customer, they're actually using Raspberry Pis to do the rendering for their OTT. So just to give you an idea as to just how efficient things like HTML5 can be sort of as we're moving forward with stuff. So some of the future trends, things that we're seeing, of course, when we're talking about data, and of course, there's lots of ways for us to look at this, but I'm trying to focus here on data and centralizing it. And the key here is your return on investment with the architecture of what we have today. Through the advantage of the cloud, we're not restricted to a facility. We're not restricted to a workstation, for example. Also, by moving everything and centralizing our content and utilizing with cloud architecture, it opens us up to other platforms. Like, we're platform independent in that you're not tied to a PC that you got to sit in front of. You open up a web browser to connect to your data. So you can use an Android, you can use an Apple, you can use whatever browser you want. You have access to it. You're not tied to a dedicated workstation or application, these standalone applications. And of course, the ability to manage, you got real-time content coming in. So this is your return on investment. You're going to require less people to manage that content. You'll be looking at social media posts, and they're all going to be centralized in one place so that you can moderate it from there rather than having to go out and search social media and copy and paste things back. So you can do more with less people. So again, this is the trend as to why we're moving to, centralizing all of the data, centralizing all of our graphics into these content management databases. Advertising possibilities. As you've seen from these screens, we have new screen real estate. In our traditional broadcast, you'd have to wait till a segment break before we actually saw our 30-second program. Now with these L bars, with the advance of the graphics, we can actually have a new screen real estate so that we can actually, through our as-run logs, basically found new time that we can actually, integration with traffic and billing systems as well is key to any of this data integration. So as we create our as-run logs, the ability to reconcile that with our billing systems. Also to future-proof. So what we're looking for in a data system today is, again, you don't want to be tied to any of the older architectures. And in the cloud, again, future-proof is to be able to normalize the data and from all platforms. Now, once we've normalized that data, again, to be able to share it, the key here is to be able to provide it in other formats. So whether it's in an XML format, broadcast favorite format, for example, a BXF format for some scheduling information. Again, once we've normalized that data, to be able to adhere to various standards and be able to share that data rather than have it locked into a particular station. The flexibility of data to be able to query it, and we talked a little bit about that, and these are sort of the trends that we need to see here. Not flat files where we can't do anything with it. You're reading the RSS feed story from top to bottom rather than the ability to be able to moderate, pick and choose what goes in, possibly even edit the content that's there. Part of that data flexibility comes, as I mentioned, to query, being able to pull specific pieces of data. But lastly here, the design tools. We can't get stuck on old formats and old video formats. We're seeing with signage and some of the new stuff, our design tools need to be able to adapt. So whether the design tool is able to generate stuff in HTML5, whether it supports WebM files or dash video, again, part of the future trend is these design tools not being locked into old media types. Okay, so just to summarize what we were sort of talking about, quick, the architecture as to where we've come from today. So we've sort of centralized the centralization of our data and being able to manage that real-time data from anywhere has really merged stuff that we're doing traditionally in broadcast, but really brought a lot of that into the signage markets where we're seeing it in the venues and stuff like that. Key, of course, is to be able to manage your data, aggregate it, if you will. Well, it's obviously aggregating it when it's bringing it all in there, but like, again, moderating. When I say manage, I do mean moderate, because we have Canada's pretty wide. So what you want to be able to do is regionalize some of the content. There's a lot of news, but your viewers are only interested in probably local news or something that's specific to them. So the ability to moderate and manage your playlists from anywhere is key to any of our new systems. And of course, as part of the return investment, being able to maintain audit logs to know what users logged in to change things, but as runs, as we talked about, for that return on investment for sponsorships and stuff. And then we have to keep up with, as we were saying, with today's technologies. There's all sorts of new graphic formats that are coming out. So all of our design tools and our data needs to be able to drive and help display these new display media types. And that summarizes my presentation. I can turn that over to you guys. Thank you everyone for your time, and look forward to any questions that you guys have at the end of our session today.
Thank you so much, Danny. It was so interesting and very informative. Thanks, appreciate it. Next speaker for tonight is Dave Muscat from 3 Dot Technologies. Dave will review the video wall display, a deeper look at various types of narrow pixel pitch direct view LED display. Dave is a founding partner of 3 Dot Technologies Incorporated, a video wall specialty distributor for North America based in Ontario, providing displays, processing, and mounting solutions. Previously, roles spanning his 34 years career in audiovisual includes Vice President of Sales Americas for Christie Digital Enterprise Solutions, Senior Director Control Room and Visualization Solution, Christie Digital Americas, Director of Canadian Sales for Christie Digital, and Canadian Audio Video Division Manager at Applied Electronics Limited. Please join me to welcome Mr. Muscat. Dave?
Thanks, Mansour. I'm going to share my screen here, and let's see if I have better luck than I had during the dry run. Or I've got disconnected a couple of times. There we go. So let me just minimize that screen.
Yep, you can see you, and you can see
we're okay now, right? Here we go. All right, thanks to SMPTE for having me here. Today I wanted to discuss indoor video wall display technologies, specifically in the North American market. Give me 1 second. Got a really strange video screen here. All right. There we go. Good old tech. So 3 Dot Technologies is a company we recently founded. We are a specialty distributor in the video wall solutions market, as Mansour mentioned, based out of Ontario, Canada. We've got 30 years experience in the video wall market relating to control rooms, lobby displays, broadcast, digital signage, and other related type applications. We have long-term established relationships in the Canadian and U.S. market with end user customers. And we've always been known for our sales, service, and support of the products we represent. We act as an extension of our manufacturing partners, supporting our consultants, our dealer clients, as well as end users with pre and post sales support. So today I want to talk about video walls. What makes up a video wall? Video wall components are quite simple. You have a group of tiling products, whether they're displays or projected images. You have a processor to take the content, to stitch all those tiles together and create one image. And then you have another processor, it can be the same processor as well, that takes all the content and imagery and media and moves it to the canvas. And you can do that as one image over the entire screen, or you can show multiple images anywhere you'd like to place them. Also, there's the mounting solution that either sits it on the floor or hangs it on the wall. And lastly, and as Danny mentioned, content. Content is king, as he mentioned, and is the most important and driving force of a video wall. Without content and current content and continuously changing and refresh content, no one wants to look at that video wall. And their whole purpose for putting that video wall up is because of the content. And digital signage for advertising and for notifications, and in Network Operations Center, the content is the reason they have a video wall there to manage the networks. So there are three main display technologies available. We're talking again about North American technologies. Availability of technologies varies based on requirements around the globe. In North America, we have DLP projection cube displays. We have LCD display panels, which has been mentioned by Danny and Jim earlier. And we have more recently, and a very big growing field, is indoor narrow pixel pitch direct view LED screens. Now, narrow pixel pitch in a lot of the market research data today is defined as pixel pitches less than 2.5 millimeters. It moved from 3 millimeters down to 2.5 last year, and everything below 2.5 is considered narrow pixel pitch going forward. Recently discontinued video wall technologies are those mini cubes, and mini cubes were the transition away from large display projection cubes, and they are microtiles is one, and you'll see a shot of the morning show there with a microtile set, and also laser phosphor displays, which are mini laser cubes, and that is a site at that used to be in GE Canada, may or may not still be there. And every time I move my mouse, I lose my cursor. There we go. So DLP projection cubes, we'll touch on this a little bit. What is a DLP projection cube? DLP projection cubes were mainly used in network operations centers. You saw them a long time ago in digital signage applications, but in digital signage, DLP cubes quickly disappeared and became LCD screens. So what makes up a rear projection cube is a projection engine, that's the black box in front, the cube enclosure itself, which is the black metal case structure, a large mirror inside, which is pretty much the size of that entire cube, and a rear projection screen, which accepts the image. And that's, again, one piece of the puzzle of the tile. The engines have LED illumination systems that can last up to 65,000 hours. They took over from lamps many years ago, which only ran up to about 10,000 hours. So this allowed customers to run many years without maintenance. They also then started creating laser phosphor-based engines and RGB-based RGB laser engines as well. And these allowed better colors to be shown, especially with RGB laser, and increased brightnesses. But some of them had better longevity, some had worse. Laser phosphor was down about 20,000 hours and went up from there. RGB laser was tunable based on the amount of light you wanted on that screen. These cubes came in various sizes, anywhere from 50 inch to 80 inches in diagonal, and had multiple resolutions and aspect ratios of 4:3, 16:9, and 16:10 for SXGA Plus, HD, and WUXGA. The one big selling feature for this projection cubes were they had fantastic small pixel pitches. They ranged anywhere from 0.53 to 1.2 millimeters, and were able to be used for close proximity viewing or further viewing. The biggest problem with DLP projection were the depth of the cubes. Cube depths ranged from 20 inches to 40 inches deep. So whenever you needed to put these in a facility, you had to dedicate a large amount of space to these cubes. And slowly LCD and other technologies, because of the real estate requirements, started eroding the requirements, and DLP projection cubes going into the installations. So competitions with LED, as LED prices started dropping and LCD quality got better and longevity improved, the end users started leaving DLP projection cubes, and it forced manufacturers to exit the space regionally and globally. And realistically, in December, Mitsubishi left the display business globally and exited. And right now, most of our end users, we were working probably on a half a dozen projects in Canada alone for DLP projection cubes, and as of that announcement, every one of them moved to LED or switched to LCD depending on the budget they had. So that's now starting to dry up very quickly. In 5 years ago in North America, we had 5 manufacturers representing DLP cube technology. Today, there's only 1 left. That doesn't mean there's only 1 left globally. It just means in North America, that's all we see that will sell product, that are selling product into this region. LCD, this is our next display technology. There are 2 types of LCD types of displays. We have discrete large format LCDs. Basically what these are discrete panels that we've seen in Jim and Danny's presentation, where they're used as individual monitors or TVs, and also used in boardrooms, lobbies, and other areas where single-use monitors are required. But in many cases, and security is one of them, where cost is an issue for large video walls, they've put these together to create video wall canvases. So one of the issues you'll see is they have large bezels that can break up the picture. But if you're looking at a bunch of video images and that aren't moving across the boundaries of the seams, then there's no real issue about the thickness of that seam. The next technology we'll be talking about is video wall format LCD panels. These panels were designed to have very small bezels and allow one contiguous image to be looked at or act as one digital canvas, and have a group of tiled array monitors act as one image, where you can then place one image or multiple images as well. So why would a customer, or why would somebody choose LCD displays? Well, they have fantastic resolution. At 4K, a 4K monitor at 43-inch diagonal equates to a 0.25 millimeter pixel pitch. And if you're looking at, and everything is going to pixel pitch resolution references because of the quick migration to direct view LED, and everything is now based on what that pixel pitch is. So TV screens or monitor screens are as low as 0.25. They have great color. The colors have been improving year over year as technology improves. The lifespan is fantastic. You're seeing 30,000 to 50,000 hours as the LCD technologies improve as well, as along with the backlights getting better and better. They're lightweight, they're easy to install, easy to mount. They consume low amounts of energy, and you can create large canvases, digital canvases, at affordable prices. So that's generic for LCD panels. So the first type are the large format LCD panels that we're going to look at. They range in sizes anywhere from 43-inch up to 98-inch, with many stops in between. They're all 16:9 aspect ratio now. Computer monitors as well over the past number of years have all changed to 16:9 formats. With HD, UHD, also incorrectly known as 4K, and quad UHD, also incorrectly known as 8K. But that's what we're seeing out there in the marketplace for naming. Backlights. The backlights you see, the old CFL or have been replaced with edge lit LED or direct lit LED. The LED, the change from CFL to LED gave the televisions their new names of LED TVs away from LCD TVs. The current TVs are all LCD TVs except for OLED. They just happen to have an LED backlight. Mini LED is going to be the next product that takes over as a backlight, and what that does is that gives you more points of light, which improves your black levels, improves your point of light on those pixels. Therefore, you have more control of the contrast and the brightness, and you can create better imagery and with improved quality. On the supply side, a year ago, Samsung exited the manufacturers. We used to have two main manufacturers of LCD panels globally, both Samsung and LG. Samsung exited the marketplace for manufacturing. LG decided to exit the commercial manufacturing and OEM supply. My apologies for the dog barking in the background. They've kept the LCD for their own products, and they've renamed them as nanocell technology. The commercial grade LCD panels have been now taken over by BOA and other Chinese manufacturers and other manufacturers actually around the APAC region. And this is what you're seeing now being put into monitors of other manufacturers' products outside of LG and Samsung. Large format OLED and quantum dot displays. So we'll talk about OLED. You're seeing more and more about OLED all the time. Similar to plasma, OLED is a self-emissive technology where LCD requires a backlight, which passes through a TFT or liquid crystal panel up through a color filter. OLED doesn't require a color filter. It uses RGB OLED technology, which uses TFT as the LCD as a gate to control the image on the screen. OLED, since it is a self-emissive technology, does have brightness limitations. You'll see OLED technology out there hovering around 400 nits. As you go above about 600 nits, the color saturation starts to be affected, and the color gamut starts to be reduced, and they start to wash out. So they keep the colors for OLED technology down around the 600 nits. You do have a risk of image retention, as you do with some LCD and as you did with plasma technology. Quantum dot. Quantum dot's a little bit differently, as OLED is an LG technology. Quantum dot is a Samsung technology. What quantum dot is it's a molecular design of nanotubes. Nanotubes have a chemistry in them that, when excited by blue light, either change colors. So what they use in today's technology is they use blue light created by either LED, or by LED today, and they generate red and green and light from those nanotube technology as the colors that comes from Q dot, quantum dot. Currently, quantum dot is used as an enhancing technology with LCD displays. So currently, in a typical LCD display, you have a white backlight, you have an LCD panel which creates your image, and it passes through a color filter which creates your colored image on the front side. With the enhanced quantum dot, instead of a white backlight, you now have a blue LED backlight. The blue backlight passes through the blue color filter, enhancing the blue from that color filter. You then have the blue LED light now exciting the red and green nanotubes, which is your quantum dot, creating red and green imagery and colors, which also then passes through red and green color filters, enhancing that LCD screen and creating a better color gamut from an LCD screen. The next gen we'll see is they'll start using they'll start replacing the color filter and getting rid of it entirely, and use nanotube or quantum dot technology to create the red and green light with a blue LED backlight, which passes through a blue color filter, but the red and green will pass through the quantum dots to create better colors and more saturated colors. Next, Samsung and others, and you'll see if you that Samsung has already purchased, I think it's about 5 million OLED panels from LG, and their intention is to marry the technology with quantum dot technology to create an enhanced OLED technology, which gives you the benefits of OLED, but enhanced colors of quantum dot and enhanced brightnesses. Quantum dot can generate up to or handle up to about 5,000 nits of brightness, where again, OLED on its own can only, with color, can only handle up to 600 nits. So the next one are video wall display panels. These are LCD display panels that are in video wall formats. So the current size we see today are 49 to 65 inch. And because of recent changes with Samsung exiting the commercial panel business, there's been a stall on the 65-inch panel. The 65-inch was a narrow bezel product that had UHD resolution. So that's now gone quiet as the other manufacturers are trying to catch up to manufacture the product. Resolutions right now are in the HD resolution for the 49 and 55, and in the 65 you get the UHD or 3840 by 2160 pixel resolution, also known as also called 4K. Again, backlights for video wall panels are only direct LED. They don't use edge lit displays here. For LCD, OLEDs are coming into play right now with some video wall tech just starting to use OLED right now. Bezel sizes for LCD have been standardized. They're called UNB at 3.5 millimeters, XNB or extreme narrow bezel at 1.8 millimeters, and razor narrow bezel, which is the latest tech, at 0.9 millimeters. And that rating is an image-to-image measurement. That's not the size of each bezel. So when you add them together, you double it. That is the size of the image-to-image bezel. The features you see in video wall display panels are processor-less tiling. So if you have a 4K or a quad UHD image coming out of a PC or a playback device, you can feed it to a single display, or you can feed it to 4 or 9 displays, and it can be shown over that entire array of monitors. They also have auto color matching now, and pixel shifting to reduce the burn-in for static images. One thing we're starting to see right now is in the large format discrete panel category, the bezels have been getting smaller and smaller as time goes by, and right now we see a 70-inch discrete panel with a 4.4 millimeter bezel with tiling features and auto color features. So that means they're trying to use digital signage type products meant for individual use and have them set for or representing of video wall panels. And it's an interesting thing to watch as these panels migrate and quality gets better. The next part of the presentation is talking about indoor narrow pixel pitch direct view LED displays. This is the biggest part of the market that's growing in display technology today. Broadcast studios have already stopped buying any LCD monitors. Projection cubes have gone. Projection devices have started to disappear. Pretty much 100% of the broadcast on-air studios have gone with LED technology, and a lot of the XR studios you see are using LED technology as the backdrop. If you look at the Mandalorian set, that entire backdrop, the backdrop set is all LED, narrow pixel pitch LED with a slightly larger pixel pitch for the ceiling. So there's no more green screen. They're actually shooting full content on the screens, and the actors are working with the XR set on the LED screen for more realistic viewing and better quality as well. So why LED? Why is everybody moving towards LED? Well, first of all, it's a bezel-less design. Pixels, these tiles of pixels are placed together, and you basically build as large of a display or screen as you wish by stacking these little building blocks together. The pixel pitches have finally gotten smaller and smaller from 2.5, and you can get them as small as 0.5. Realistically, you're seeing some 0.9 out in the marketplace. It's very rare to see a 0.5 millimeter pixel pitch. 1.2 seems to be the most of what we're seeing in network operation centers, and then we'll see 1.5 and above being used for digital signage type applications. They have long lifespans. You can get LED displays that will last up to 100,000 hours, and these time measurements are based on 50% brightness of the product. They offer best color, and with LED displays right now, you can get DCI P3 color space available. Rec 709 is pretty much typical for day in with HDR10 for day in, day out quality of LED screens. There's no image retention or burn-in from an LED, a narrow pixel pitch product, and you have a very small panel depth. Similar to some of the LCD TVs, LED panels can be as thin, actually less than 2 inches in depth, and click together like building blocks. And they have excellent contrast ratio with phenomenal brightness. And what we're seeing right now is a standardization of tile sizes using 27.5-inch diagonals as building blocks. And the reason they chose 27.5-inch is because of the popularity of the 55-inch video wall panels. So a lot of LED manufacturers, especially indoor, have gone after that 55-inch video wall LCD display, and with a 2x2 array of their 16x9 27.5 diagonal panels, you can build easily and match a 55-inch panel. So LED is a little bit different than everything else because a tile isn't a proper resolution. A single tile won't give you an HD image. So what you're seeing out there is education on what makes an HD size, and if you want UHD, you multiply that by a 2x2. So in a 0.9 millimeter pixel pitch, in this type of format, you'll see most of the manufacturers moving to a 3x3 array of tiles. So that 3x3 array of tiles in a 0.9 at 72 inches wide gives you that HD screen. A 4x4 gives you an HD screen based on 1.2 mil, a 5x5 at 1.5 mil, and a 6x6 gives you an HD image at 1.9 millimeters pixel pitch. And because of that little bit of confusion as to how you put a system together, LED manufacturers are trying to make them very simple to use and also simple to buy and simple to inventory. These are LED systems are custom made most of the time. So by creating these building blocks of 3x3, 4x4, 5x5, and 6x6, they can offer simulated large format monitors. They'll even put them on a stand for you and sell them with an audio system, some collaboration software, and put an all-in-one package together. And you'll get them in 110-inch, 138-inch, 65, and 220-inch, all at varying pixel pitches. But each one of these displays is a 1080p or HD display. So if you can imagine the resolution of a 220-inch display at HD compared to 110-inch. So you can also take that 110-inch, which is the 0.9 millimeter pixel pitch, multiply it by 4, and you'll get a 220-inch diagonal 4K product. So hopefully that clears up a little bit about pixel pitch and how that tech works. Now, the actual individual pixels, what makes them a pixel? Well, narrow pixel pitch have moved to what they call SMD, so surface mount diodes. They range in size from 2.5 to 1.2. These are surface mount. They are on the LED modules, and those modules then get attached to the LED tile. The LED tile is that 24-inch wide tile, and it will hold a number of these panels, typically anywhere from 9 to 16 of these panels. Just snap into place and sit on top of that on that LED panel. An SMD chip basically is an RGB array of LEDs on a substrate with semiconductor crystal. There is a conductive wire and a lens that makes up the SMD pixel. We then move to mini LED, and these are terms you've probably heard. All mini LED, it's a bit of a some confusion out there. Mini LED is pretty much just SMD in a smaller package format. And what you'll see here is instead of a single diode or single package of SMD placed on a on that LED module board, you'll now have 4 of those pixels placed on an LMG on the module board. That makes manufacturing a little bit easier, but it does, if you have a failure, instead of losing 1 pixel, you'll lose 4 pixels. The next thing you'll see is chip on board. Well, chip on board is pretty much just mini LED with a coating over it to protect the LED. SMD and mini LED are very fragile. The LEDs are exposed on the surface, so if you rub your hands against an LED wall, you'll feel how rough it is because you're running your hands over those LEDs, and they can break off quite easily. Chip on board or COB technology using mini LED has an epoxy coating over top of the over those LEDs to protect them. So when you run your hand over the surface, it feels more like a traditional screen, more like a glass feel, and you can't damage the LED modules by running your hand over it. There's also new technologies called flip chip, or this takes COB, and COB still has that bonding wire that's required. So to remove that, they flip the chip over, they attach it to the substrate, removing that bonding wire. And in a lot of cases, many of the failures of traditional SMD and chip on board product is because of that bonding wire. So by flipping it over, it actually improves the longevity of the product and increases the MTBF. Glue on board is a process that's being used for SMD, just to coat the top of the LEDs to make them smooth, much like a chip on board process, but instead of using the mini LEDs, they're just pouring the epoxy over top of the standard SMDs. And then the next product we're going to see coming out, and it's a Samsung product, it'll be a quantum nanorod LED. And what they'll do is they'll take an LED, again similar to a backlight. They'll take an LED or a mini LED. They'll place those colored nanorods over each of the colored chips or the blue chips drivers to create colored LEDs for better colors than what the LEDs were doing or creating. Micro LEDs, you'll start hearing about this. This is where LEDs or indoor NPP LEDs are going.
Sorry for interruption. We are running out of time. If we can just make it a little bit shorter, because we still have one more presenter. Thank you.
No worries. I'll cut it down right now. So micro LED has a pixel pitch of 3 microns. Oops, sorry. And my computer just, oh, there it goes. They occupy 1% of the pixel pitch area. You'll see all that black area. That increases the contrast ratio considerably. And they're also placing driver circuits on those on that pixel pitch. They have a peak brightness of 1,000 nits, so you're getting a lot of brightness out of a little area with huge contrast ratios. Currently, Sony is making this product, and they're using printing techniques to print the circuits together, as opposed to pick and place, which is the current process. I'm going to skip over how you do this, or how you place where you place yourself with LED, because resolution is a factor. And in traditional SMD, and you'll see gold wire versus copper wire, that will vary your quality, as will your video slicing and processing. I'm going to skip over the mounting structures right now, but it is a very important part of any installation today, because without proper mounting, you've all seen the videos of walls falling on the anchor in Brazil and other locations. Special attention to mounting structures are very important. That's it. Sorry, Mansour, for taking a little bit longer. Appreciate your time.
Thank you so much, Dave. It was really interesting, very amazing. Thank you. Because we are going to have a short time, but we still have one speaker. Let me, without any delay, I introduce the last speaker. The last but not the least speaker for tonight is Allan Fernandes from Christie Digital. Allan will cover technology evolution of cinema projection. Allan is the Director of Production Management at Christie, focusing on the intricate and specific projection technology needs for the cinema industry. He leads a multidisciplinary team to ensure these needs are well aligned with the Christie core offering of cinema products for the industry, including filmmakers, post-production facilities, and exhibitors. Allan's experience in cinema manufacturing spans more than 16 years, and today he focuses on the latest portfolio of RGB pure laser digital cinema projectors. As the industry transitions to solid-state illumination over traditional lamp-based technologies. He holds a bachelor's degree in electrical engineering from Lakehead University in Northern Ontario, Canada, and a PhD designation. When he is not busy with the cinema, You can find Allan in his garage, tinkering with cars and spending time with his family. So here is a cinema, family, and car lover. Allan?
Thanks, Mansour. All right, can everyone see the presentation? Oops.
Yes, sir.
Yes, we can.
Okay, I'm going to try and keep it brief here. I know we're running out of time. Usually I start off, especially in times like today, a little bit of an update on what's going on with the cinema industry, the exhibition industry. As everyone knows, it's been quite a year. In 2020, most cinemas were closed down, especially in North America. North America, specifically the U.S. box office, suffered the worst globally, as the U.S. box office was down 80% over 2019, compared to 71% globally. That was really compounded because of the tentpole movie releases that were just pushed out to 2021. We didn't see as much of a negative effect in other countries, especially in APAC regions, China, Japan, where they have a lot of local content creation, so they didn't suffer as bad because their local box office actually did quite well considering during the pandemic. In fact, Japan had this single movie called Demon Slayer, which was back in December, I believe, and it did $350 million US, which was a single box office record for Japan of all time, and they did that in the middle of a pandemic. So we're seeing some good, strong recovery signals in the market. AMC, there's a lot of discussion around AMC Cinemas, as most of you know. Probably they're one of the largest, or the largest, depending how you slice it, the largest exhibitor in the world. They were able to raise another $915 million in operating capital at the 11th hour. And this whole Wall Street bets, I'm not sure if you followed that issue going on with GameStop and the hedge funds that were basically shorting GameStop and AMC and a couple others. And a Reddit group kind of got wind of it and basically were buying up all the stock and basically short squeezing the hedge funds out of their position. This actually gave, believe it or not, gave AMC a nice little lifeline, because it was able to eliminate $600 million in debt from their second largest debt holder, which is Silver Lake Holdings, a private equity firm. So they were able to convert that debt note into stock shares at the right time and come off with a profit, which helped eliminate that $600 million of principal interest off of AMC's balance sheet. So they have a decent runway now. And now, as we see, things kind of recovering, especially in the North American market. Like we just had a 3-day domestic box office of $54.2 million, which is the highest total for any weekend since the onset of the pandemic in North America. Very good news. Godzilla versus Kong, already more than $400 million globally. And we've just got, high vaccination rates in the US. Sounds like the total population will have access to the vaccine by June. And we got a ton of movies coming out this year. So we're seeing a lot of pent up demand in the cinema world. So it's good news there. So just kind of breaking this up into a kind of an evolution of Illumination Technologies for cinema. I'm not going to go into too much detail, but it all started off with the carbon arc long before my time. Probably in the early 1900s, this became more prominent in cinemas. Of course, there was basically, this is where I would say where projectionists were actually, they were working hard. They were constantly working on those projectors, constantly adjusting the gap in the rod during the movie. And typically, some of those rods only lasted 20 minutes, and they typically had 2 projectors per screen, so that when they did the reel change, it would switch the carbon rod to a new one. So it was labor intensive. It required, technical, highly trained technicians to do this kind of thing. And this went on until about the 60s and 70s, when xenon lamps became more commonplace, basically replacing all of the carbon arc systems by the mid 80s. Again, xenon using an inert gas to maintain that arc, very close, very stable, broad spectrum light. And it was really during a time when industry was really pushing for more automation, in the sense that, now xenon lamps didn't require, a projectionist for every single screen. Instead, now they could have an operator that could manage all projectors in a complex. And again, and since the onset of xenon in the 70s and 80s, it's still a very relevant technology today. Over 150,000 screens are still burning xenon lamps today, in fact. again, because of that evenly distributed, that broad spectrum light, it closely matches that DCI spec and the daylight spectrum. It was kind of a good fit for cinema. Very proven, reliable, very familiar in the cinema industry, proven track record, all of those good things. Some of the downsides requires this thing called a yellow notch filter. If nobody knows what a yellow notch filter is, it's basically what it kind of sounds like. It takes out some of that yellow light so that the red and the green primaries can hit their target points, their DCI P3 target points. Pretty much every projector that's not pure RGB requires some kind of yellow notch filter to achieve that. Xenon, has a high power consumption comparatively speaking to other technologies today, and really wasn't bright enough for those premium large format screens, especially for 3D. And then what we call the étendue is, think of étendue as how tight of a cone can you make that light beam inside your projector optics. The smaller étendue, the tighter étendue, the less diffraction you get in your optical system, which means in a DLP-based projector specifically, you'll be able to squeeze much more high contrast capabilities out of that system. But a wide optical étendue limits you in terms of high contrast capability. So in the 2010s, I'd say 2012, 2013, Mercury lamps started making their way into the cinemas as a low-cost alternative. They've existed in other projection applications for many, many years. And I say it really just offered a low-cost alternative, and I say that's really where the benefits ended for cinema, because you still need that yellow notch filter, and because Mercury lamps are so red deficient, you had to take a lot more yellow and basically green out of your system to basically match your red deficiency, which basically meant you lose 30 to 40% of your light if you were being kosher and making sure that your screen was hitting the DCI spec. And then, color rendition of a Mercury lamp, not as stable as Xenon. So as a lamp changes, the color rendition changes, which technically would require for more frequent calibration. So really only suitable for some of those low-end, low brightness screens where costs was really the only driver. Little bit of the yellow notch filter. I'm not going to go into too much detail since we're kind of out of time, but that's what it looks like, and it's tuned for that specific projection system depending on what type of illumination technology it has. So then, next came laser illumination, and it was really for, the quest for the perfect image in terms of, what kind of elements could come together to bring high dynamic range, or HDR, into cinema. Brightness, of course, contrast ratio, and color. Those are the three kind of key core ingredients to bring an HDR style system to cinema, the kind of a leapfrog in projection quality and performance. So in 2012, Christie launched the first pure RGB laser projector demos around the world, and this was with the Christie CP42LH, as you can see here. There was a projection head that was fiber coupled with up to 12 different laser modules. Each laser module in this rack, about 5,000 lumens each. It's a white light module and carries a single fiber into the projector head. It was a leapfrog in brightness, so whereas you could kind of top out 30 to 32,000 lumens out of a xenon-based projector, you can get 60,000 lumens out of a single projector head. So that really solved the problem for premium large format 3D. Best color performance in terms of the primaries, the red, green, and blue primaries that you could basically pick based on the wavelength of the laser device. It was really the only technology or projection technology really able to achieve full Rec 2020 color. And then, of course, the low étendue of pure RGB laser, because you have individual narrow collimated beams of light. You get very high contrast, basically tripling the contrast out of a standard DLP-based system from 2,000 to 1 on-off to about 6,000 to 1 on-off in a pure RGB system. And then, of course, you have the no conversion losses. You don't have to use a yellow notch filter here because you just pick the wavelengths of the lasers that you need to create your color profile. Now, there were some definite drawbacks to this technology. The biggest one really was that it was prohibitively expensive. That system there when it was debuted was probably close to $500,000. I can't remember, but obviously prohibitive for any cinemas, especially for mainstream cinema. So that return on your investment only really made sense for those really large PLF applications. Part of the problem was the Gen 1. Well, I'm just going to call it Gen 1 and Gen 2 RGB laser. You'll hear that in this presentation. But Gen 1 green lasers are pretty inefficient. They're basically a frequency doubled IR infrared laser. Same kind of, if you have a green laser pointer, and it stops working for some reason, and you know you put a fresh battery in it, don't look at it, because it just probably means that the crystal oscillator on top has failed, and it'll still be pushing out an IR beam out of that, which is very, very dangerous for your eye, of course. And because of those green lasers and the red technology at the time, it really required aggressive cooling. Basically, every single one of those modules in that rack had a built-in chiller. So the power savings that you would get in the efficiency of laser light, were negated due to the high cooling overhead that these Gen 1 systems had. And then, of course, we had the issue of speckle, and some of you may know what speckle is. Probably most of you do. Really a big concern in the cinema industry because of the type of screens that are used, especially when you get into the high gain screens or silver screens for 3D. That speckle effect becomes much more prominent, and it's very, very distracting and a problem for the technology. So we took this projector around the world. We debuted in Amsterdam at IBC, 63,000 lumens for the movie Hugo in 3D. And then 6 months later, we installed it at the AMC Burbank in Burbank. And we did a 2-week commercial engagement, over 100 shows, a bunch of different movies. It was a 65-foot silver screen. We installed screen shakers because that's one way to mitigate the speckle on the screen. There's a couple other ways that I'll talk about in a later slide. So we had a lot of, the technology was very welcomed. We knew that it was a step in the right direction for cinema. Display of illumination evolution technology anyways. But again, the price point, the economics for mainstream just didn't make sense, but we had to start somewhere. So to address that economic situation, another type of laser technology came out called laser phosphor. And laser was kind of, at this point in time, was kind of a fad. It was like the new big thing, the next big buzz in projection. So kind of laser phosphor and pure RGB kind of grouped into the same category of being the next best thing. So in general, a laser phosphor projector uses blue lasers only to generate that white light. In some cases, and now we see blue lasers and red lasers, so you can augment with red devices to add color and efficiency boost. But let's just, for the sake of this, we'll call this just a straight up blue laser phosphor projector. Because blue lasers have already been, we're already a mature technology with the dawn of the Blu-ray system. For over a decade, they basically had achieved economies of scale, and we're at the lowest priced laser device you could buy on the market. So you don't need to cool them aggressively, far cheaper than the red and the green. You could get high lumens out of it. It addressed the logistics and the maintenance aspect of not having to change any lamps. And because it uses a phosphor conversion to generate that light, it's not a collimated beam of light. So you do minimize that speckle. So basically the way it works, you have a bunch of blue laser banks here on the right side. They pump this phosphor wheel. So blue laser light hits this yellow phosphor. You get a lot of yellow light that's reflected back, goes through a series of optics, gets mixed with blue light. So yellow is really a combination of red and green, and then you get white light. So it sounds like a home run. Apparently, the problem is you start getting into some of the conversion efficiency losses and the requirement for a yellow notch filter, which I'll talk a little bit about here. Slightly better efficiency than a xenon-based system. Xenon-based systems were like 3 to 5 lumens per watt. You get 4 to 7 lumens per watt depending on the type of laser phosphor projector, especially if it had some red boost in it. But the yellow notch filter wastes 40 to 50% of that light to achieve DCI-P3, plus the compounded on top of that conversions efficiency of that phosphor wheel. So in most cases, a blue laser phosphor projector really only uses about 20% of the light in a typical cinema application. And then you still have that wide étendue because the reflected light off the phosphor is wide angle, so it limits your high contrast capabilities. You also have some other conversion optics that degrade over time, so it does have a little bit of a lower lifetime. So you really have to factor that in into the total cost of ownership, which is really the critical determining factor for most exhibitors on choosing next generation technology. However, still a popular choice. Some of those smaller screens, low usage screens, remote sites where lamps and maintenance can be problematic, especially in very, very remote parts of certain countries, and also where speckle is particularly sensitive on smaller screens. Laser phosphor is still a popular choice today for cinemas. So we knew that we need to develop a Gen 2 system, and it needed to be significantly cheaper to make it into mainstream cinemas. And in 2017, we debuted what was the first, what we call Gen 2 pure RGB laser projector. It was called the CP4325 RGB. This projector doesn't exist anymore, although it's called a 4330 RGB, and it's part of a whole suite of pure RGB Gen 2 laser projectors in Christie's portfolio of digital cinema. The big change here was new green laser technology, right? We had, instead of having those really inefficient frequency doubled IR lasers, we had what's called direct emitting green laser diodes, 4 times more efficient, didn't have to use chillers to cool them. Red lasers went on a big tech innovation as well into these multi-die packs that you can see on the right. Again, much smaller footprint, all-in-one cooling integration, no chillers, and that resulted in a much higher efficiency, 9 to 12 lumens per watt. So now we're talking significant wall plug savings over lamp-based technologies. Low étendue allows us to get that 6,000 to 1 contrast, and then the wavelength diversity on our pure RGB is constantly increasing and evolving, and I mentioned that because wavelength diversity is really the biggest bang for the buck when it comes to addressing speckle on screen. So the more wavelength diversity you have in red, green, and blue, the less speckle you're going to have, the less coherent wavefronts you're going to have coming at the screen, creating that interference effect. You're going to have more wavelengths spreading that out. And of course, if whereas a Gen 1 system was close to 10 times the cost of a Xenon cinema projector, these Gen 2 systems are only about 1 to 2 times the cost of a traditional Xenon cinema projector. So now there's the mainstream affordability is finally here. And just to kind of give you a snapshot of the projectors, and I'm going to call it native color gamut. The smaller one, which is the Rec 709, is typically what most TV and broadcast systems are spec'd to, and that's basically what a mercury lamp-based projector or laser phosphor and some LED applications for cinema that I'll mention in a later slide. The middle triangle is really the DCI P3. That's the digital cinema spec, and that's what very closely matches to the native spectrum of a Xenon lamp. And then, of course, you have RGB laser at the bottom, which is a technology that can be used to achieve the UHD TV spec for Rec 2020. So, laser projection, specifically RGB, will become the standard for cinema exhibition. I think it's already becoming the standard. It's going to bring much higher brightness, much more color saturation, higher contrast, all those key elements for HDR style systems. And then, of course, it brings in the maintenance-free aspect of not having any lamps and change, and basically having a light source that lasts the life of the projector. And in the case of life of the projector, 30 to 40,000 hours equates to 7 to 10 years for most cinemas. And then, of course, the total cost of ownership is, like I said before, is really a critical deciding factor, and that Gen 2 RGB is really checks the boxes for that. There's been a lot of talk on LED for cinema, specifically in 2017 was when it made its first appearance as an option back at CinemaCon. CinemaCon showcased a bunch of LED technology from Samsung and Sony. Spectacular brightness and contrast, really positioned themselves as the ultimate HDR cinema display. So there's a number of articles that were making headlines. Samsung's LED cinema screen passes the DCI compliance test. That was a big one. And so there's a lot of rave about LED in cinema. And don't get me wrong, there's a lot of benefit there. I think the biggest one is the brightness. I mean, we have LED screens that are 400, 500, 1,000 nit screens. That's more than 10 times the brightness that any projection system could achieve. Great black levels, superior contrast, just an incredible dynamic range with LED emissive displays. Typically Rec 709 for color, but with proper tuning and binning of the LEDs, the diodes themselves. The color can exceed DCI P3, so no issue there on the color front. So, those three elements: brightness, contrast, and color. Really bringing HDR within reach to cinema. There were some technical issues early on. There were some reliability concerns with the different panels, with pixels dying, uniformity. Of course, there's the audio problem because an LED screen is not passive like a conventional cinema screen. So now you have to rejig your audio in your auditorium to make it sound like the audio is coming from behind the screen. LED technology has evolved quite a bit over the last 4 years. A lot of these issues are not really as relevant today as they were 3 or 4 years ago. But probably the biggest one is that the existing cinema infrastructure is not really well suited today for LED, especially if you're trying to retrofit. Many challenges with power delivery and weight constraints for many conventional theaters. But aside from the technical challenges, I think the biggest issue is the business case for LED. And of course, exhibitors are in the business to make money. And I think a lot of people here know that exhibitors is not a big margin business. It's a very thin margin business. So, you know, properly installed lamp projectors, good enough for most audiences. And that, you know, studies have shown that most audiences will pay like a 10 to 20% more for a ticket for a premium experience. Looking at Gen 1 RGB, 5 to 10 times the price of conventional xenon lamp projector. Gen 2, now we're down to 1 to 2 times. But the latest LED walls are still around 15 to 20 times the price of a lamp projector. So that basically puts it into a non-starter for mainstream cinema, at least today. Until we can get the price per pixel down significantly, it'll stay this way, I think, for the most part. However, LED does bring some unique applications to cinema, specifically one, drive-ins. And I think we saw this last year with the as the pandemic, as everything was closing down, there was a lot of portable LED screens that were popping up in Walmart parking lots, in other regions of the US, where they basically could run drive-ins throughout the day and at dusk, which could potentially open up a significant revenue opportunity and increase the showings per day versus just having 3 or 4 shows in the middle of the night. And then, of course, the other one here is the VIP, the in-theater dining experience. LED displays actually work quite well in this type of environment because you would want to have some kind of ambient lighting to have food and beverage service and not affect the presentation. So where does that leave the future of cinema? I think, you know, the pandemic, everyone knows it's disrupted the cinema industry, or any industry really centered around public venues. You know, just shortly before the pandemic, most exhibitors were kicking off. They were basically exiting the virtual print fee model. They've had their Gen 1, you know, cinema projectors for now 10, 12, 13 years. So they were basically end of life, and they were just kicking off a technology refresh to some kind of solid state laser platform. But unfortunately, the pandemic has kind of put a pause on everything as exhibitors were, you know, largely closed last year. Cash flow and balance sheets will take some time to return to normal, or a new normal, what that might look like. So as a result, exhibition is just far more CapEx sensitive now. We're actually seeing a reemergence of xenon as a low CapEx alternative, believe it or not, in the short and medium term until you know, exhibition can kind of realize what the new normal is going to look like. Is the occupancy rate going to fall permanently? Is new social distancing restrictions going to limit the occupancy for theaters? That kind of thing. But I think what we're seeing today, as far as the pent-up demand for cinema, cinema will always be around. It's weathered major storms in the past 100 years, and it'll weather this one as well. So what that's going to mean is that, you know, exhibition is just going to put a far more scrutiny on total cost of ownership. Anything they can do to reduce CapEx and OpEx expenditures. So we're starting to see new financial models, and we're working with partners to help with these financial models to help offset those CapEx constraints that they see today. Pushing for more automation and efficiency of projection booth. We're using things like Christie Mystique, which has never been a cinema software application, but using that tool, software and hardware to automatically align the projector, keep it automatically focused, keep it automatically converged on the screen. So it kind of minimizes how much maintenance on-site maintenance has to be done by a human. And I think that the demand for a differentiated experience is going to be even higher as time goes on. So strongly believe that pure RGB laser projection will be and is the best positioned to become the standard for cinema. So I think that is my last slide. Hopefully I didn't go too fast. Thank you very much for taking the time and having me on your panel.
Wow. Thank you so much, Allan. It was amazing. It was so interesting to see how the projection industry has been evolved, and the projection industry has been evolved. And appreciate it. Thank you so much, Allan. Before you go, my colleague Andrew Thomas collected questions, and he will read some question, and I will ask the all panelists to be on the screen, and I'm handing over to Andrew Thomas. Andrew?
Hi there. Yeah, at this point, we had 2 questions, but one of them was answered later on. So we're down to 1. And that was from Tony. Are LED monitor wall panels used outside? And if so, what is required for winter operation?
All right, I'll get my camera going here. There I am. Yeah, LED. There are indoor and outdoor LED products out there. Outdoor LED have been around much longer than indoor. Pixel pitches have been varying. They started off at 12 and 15 millimeter pixel pitches. They are coming down. We're seeing outdoor LED being used everywhere these days, in small pieces and in large pieces. And with the cost of LED dropping, they're even being used in place of large LCD arrays.
Excellent. That seems to be it for questions at this point. I know it's quite late. Any last minute questions before we call it? Nope, I don't see anything in the chat or the question area. So I'll throw it back to Mansour.
Thank you. Thank you so much. I would love to appreciate and thank all the panelists for accepting my invitation, our invitation for tonight. It was a great presentation, and I would love to thank you again and hand it over to Tony. Tony for some closing remarks. Tony?
Thanks, Mansour. Hey, thanks, guys. Really good. You know, it's a testament to how engaging a evening can be. We didn't lose very many people, and normally we kind of drop off at an hour and a half or so, but everybody stayed on. So thank you to everybody for having a great presentation. I found it very engaging. Thanks very much. Just a couple of closing slides. Lee, do you want to do this? Are you still online, or do you want me to just throw through it? Lee is sparking up.
No, I'm here.
Okay.
Yep. Yeah, so just quick refresh there. So the save the dates, June 15th to 17th, our technical conference. I can next slide there. Just a reminder, we have the new format there, and we've got the round table. So that's also sort of a new round conference there. So we're going to have 18 technical paper, the round table. So if you are interested in submitting a round table idea, we are still accepting that. So please send those in. If you're interested, we're still looking for some more sponsors. I guess we're next. And sorry, we're just doing our sort of soft launch now. So the website is live if you're really keen, but have the program posted till next Monday. So you might want to wait till Monday, or if you're keen on go ahead and register, you can actually go register now. So, and yeah, that's it on the TTC there. There's one other thing I forgot. No, it's okay.
Okay, thanks, Lee. Just a couple of things. The evening was recorded, so everybody that registered for the event will get an email pointing you to the URL on our YouTube channel. The elections that we just had past a little while has closed, and the results will be announced shortly. And there is no June meeting. We are replacing that with our technical conference, as Lee has been talking about. Our next meeting will be September the 14th. We get the summer off. We're looking at possibly, this is just a placeholder, CBC Montreal new IP build. And in October, we're thinking about an NAB wrap-up, which I think NAB is the week before, if that all comes to plays out the way that they're looking to do. Updates, SMPTE website is simply.org/section/Toronto. If you're not a member of SMPTE, you can become a friend, and that's the URL. But keep in mind, there are some incentives for membership during the TTC initiative. So when that comes online, do check it out. There is definitely some incentives to get you to become a member. Our social connections are the following, and I think that's it. Yeah, so everybody, hopefully you're going to get your needle soon, and that's a wrap. Thanks very much, and we will talk to everybody in the coming months. Thanks very much. Bye-bye.